just going to try and recap a problem by induction. And so we're going to prove the following using induction. The sum of the first n odd integers, which is 1 plus 3 plus 5 plus dot, dot, dot. What's the last one? Do we know what that last one is?
Is it 2n plus 1?
Almost, yeah, 2n minus 1. Nice. So, and we're going to show that that is n squared. Okay, so first of all, you're saying to me, well, how the hell am I supposed to know the green? Well, that you should be able to figure out. And how the hell am I supposed to know the blue? That one I don't care so much if you can figure out, but I'll still show you that you can. So I would give you the whole problem. I would give you this whole thing, not expecting you to find the green, not expecting you to find that blue piece there, right? So we can find that last term by getting the nth term, right? And we know a sub n is a sub 1 plus d times n minus 1. We have it memorized. If we don't have it memorized, we have it written on our formula sheet. If you want to go to the full dedication, you can get the tattoo. Just don't blame me if it hurts, right? But I'd say if you're going to do that level of dedication, it's not cheating, right? So what's my first term?
One.
Nice. What's the common difference? What am I adding every time to get to the next odd?
2.
Yep. And I'm going to multiply that by n minus 1. And when I simplify this, right, I get 2n minus 1. There it is. Nice. So that green piece is easy to find, right, especially when it's arithmetic. And that's all we're doing is arithmetic, right? We know we're always adding the same thing next to for the next term. How do I come up with that n squared piece is quite interesting. I'm looking at now that I know my nth term, I'm doing the sum from 1 to n of 2i minus n minus 1, right? And I know that I can turn that in using my summation notation, right? Using those pieces that we looked at the first day, I can get the sum of 2 times the sum of I minus the sum of 1. And for each of those, I have a formula. And notice I'm using a shortcut there. Right, I'm not putting the subscript of the indices in. I'm not saying from 1 to n, right? Just because I get a little lazy. And this is n times n plus 1 over 2. And if I sum up 1 n times, I get n. And notice what happens here. Don't let me go too fast. I just had another cup of coffee, so I feel like I might be going fast. Slow me down. You're paying for the ride. So the 2's cancel here, and I distribute, right? And notice that I get n squared plus n minus n, and I see that I get the n squared. So I get that blue piece here. But again, that one's going to be given to you if I give you an induction problem. But you do know how to come up with it. Okay, we're ready to prove this by induction. Let me get a new screen, but don't let me go too fast. Does anybody need a moment here before I go to a new screen?
I took a picture of it, so I'm good.
That's fine, but don't let me make you frantic, okay? So I want to prove, so I'm going to that next page just to clean up here. I want to prove that the sum from I equals 1 to n of 2i minus 1 equals 1 plus 3 plus 5 plus dot, dot, dot plus 2n minus 1 equals n squared. Right, so I just wrote everything that we had figured out on the previous page and just trying to make it a little bit formal. So here's our proof. Let n equal 1. Right? So on the left-hand side, I want to sum up the first odd integer. And on the right-hand side, I want to see if my formula worked, if n squared worked. So let n equal 1 on the LHS, which is left-hand side. The sum of I equals 1 to 1 of 2i minus 1, right, is just 1. It's just that first term. And on the right-hand side, I'm going to use my n squared, right? So this is what I'm calling on the left-hand side. This is my right-hand side, right? So on the right-hand side, I have 1 squared, which is also 1. So check. They worked. When you do proofs by induction, it's okay to start at 1, but what if 2 fails? And then you do 2, you check 2, and then what if 3 fails? So you check 3, and then after about 3, you're going, okay, it's working, right? But let's do one more. Let's see. Let n equal 2. Everybody with me?
Yep.
Left-hand side is the sum of the first 2, right? That's 1 plus 3, and that is 4. Let's see what happens on the right-hand side. On the right-hand side, I just have to use n squared, but for the second index, right? So the second index is 2. So 2 squared is 4. Okay, it worked. So it works for 1, it worked for 2. Let's check it for 3 without writing anything. Well, the first 3 terms, the first 3 odds are 1, 3, and 5. 1 plus 3 plus 5 is 9. Is that 3 squared? Yeah. So it seems to work every time, right? Seems to work every time. So we're thinking it's okay, but what do we want to think about? It should work for way out in the future, right? For n is 10,702,000,000, right? So, and then all we have to do is show it works for one time after that. Since that time in the future was arbitrary, and then we don't know when it is, but it works even after that, then we're thinking it works all the time. So we're going to assume that the sum is true for some arbitrary n equal k, using a different letter to make sure I'm realizing it's later on in the future. So assume that the sum from I equal 1 to k of 2i minus 1 is 1 plus 3 plus 5 plus dot 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 plus the 2k minus 1 equals k squared, right? So yes, it seems kind of silly. All I've done is replace the letter n with the letter k. But the idea is I'm kind of pretending it's a later value of n, right? The key is that can I find the next term, right? Can I find the next term? Well, how did I get the next term? What did I do? What did I do to get the next term every time?
Adding 2.
Adding 2. So my next term could come from 2k minus 1 plus 2. In fact, it does. So my next term is 2k plus 1. I want to show you that next term is 2k plus 1 another way. What happens to k when I go to my next term? Well, if the k was 10, now it's 11. If the k was 35, now it's 36. So I'm adding 1 more to k, right? So my next term should be the 2k minus 1, but the k should be the next k, so k plus 1. And of course, that is 2k plus 2 minus 1, which is also 2k plus 1. So I verified 2 ways that I can get the next term. I could think about the next term about how I'm moving, or I can just plug k plus 1 into my previous k and simplify. And you're probably going, well, how the hell am I supposed to know how to do this? You're not. It's my job. My job is to teach you all of the tricks, right? And so it's not like I came up with this stuff myself. It's been studied for thousands of years now, and I'm just, I guess, I'll put it in quotes, smart enough to understand it and explain it to somebody else. So what I want to do is take my equation and add the same number to each parts of the equality to preserve the equality, right? So we know the following is true. That if I take that sum from I equal 1 to k of 2i minus 1 and add the 2k plus 1 to it, it's the same as me taking the 1 plus the 3 plus the 5 plus the dot 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 plus the 2k minus 1 and add the 2k plus 1. So notice I'm just adding the same number to everything, so I'm keeping equality. And at the end I get k squared plus 2k plus 1. So I still know this is true. Why? Because I assumed it was true for k, and now I'm just adding the same number to each part to keep equality. How is this? We okay here? It could be a K joke there. I don't know. Are we okay, or are we okay plus 1? So on the left-hand side, there's not too much to think about, right? On the left-hand side, I still have the sum, but now it goes up to k plus 1. Sorry, 2i minus 1. And on the right-hand side, so this is left-hand side, right? I know I'm going up to 2k plus 1. On the right-hand side is where I'm going to simplify. I've got k plus 2k plus 1. And I don't know if you recognize that right away or where we're going with this, but that's factorable, right? Do you see that? Can you see that factoring there? Anybody see that? What does that factor into? It's like we're in 8th or 9th grade with the factors of 1 that add up to 2. Right, so I've got k plus 1 all squared. And don't you see that's exactly what I wanted? I wanted to show that I got some kind of n squared, right? But the n had to be the next n, right? I showed it was true for k. I showed it was true for k squared, right? Or I assumed it was true for k squared. Now I got k plus 1 quantity squared. So that's it. It's done. So the sum of I equals 1 to n of 2i minus 1 is n squared by induction. So, like, I guess you could try a homework problem in homework 3. But certainly, I would expect my computer science majors to be able to do the next 2 general sums that I wanted you to memorize, right? If you can remember, I had 4 of them, right? I had the sum of a constant was c times n. I had the sum of the indices was n times n plus 1 all over 2. I had the sum of the indices squared was n times m plus 1 times 2m plus 1 all over 6. And the sum of I cubed was n squared times n plus 1 quantity squared all over 4. So I think if you're a computer science major, you should definitely prove that one by induction. Same process. Math major also. Bio major, go for a walk or something. Do something else. Make dinner for the family. You know, something healthy. How do you feel about that? Any comments about the induction piece? And you might say, well, why are you making the computer science students do it and not anyone else? Well, because I think I'm a kind person, And you just have to agree of the truth of it for the piece that's coming in Calc 1. Okay, so if you're agreeing with everything I'm doing, that's enough. But the computer scientists are going to have to eventually program something in this vein. But all of you will see these 4 sums in Calc 1. You'll see these next semester when you're doing Chapter 5 in the Calc book. You do Chapter 2.
Is it okay?
2, 3, 4, 5. Yes, Elise?
Is it okay if we did the homework even though I'm not a computer science major?
Yes.
Okay.
But I would double check your desk to see if you have one of those pens with 4 colors on it, because you could be a nerd.
I did find 2 of those in my room yesterday.
Nice. That's funny. Thank you. Thank you for throwing that softball joke at me here. Yeah, I think math is fun, personally. And the other thing is I like to be right every now and then. So it's nice to be right every now and then. All right, so we're done with Chapter 12. I did post a tentative date for the Chapter 12, Chapter 2 test. So I'm going to start working on Chapter 2 today. There's 5 sections. I think I should get it done by next week, which would mean the week after that, or I think I have it even posted a week later than that, would be the first test. I will start talking about a process for taking exams. I will get a test review up for you. I plan on your test being very similar to the test review. Okay. So we're ready for Chapter 2. And we're talking about functions. We're talking about more than functions. And this should feel like a review, okay? So I'll spend a lot of time on 2.1. I'll spend a little bit of time, on a 2.1 is 3 homeworks, just so I could leave it at like 10 or less than 10 questions each. The first one is functions and domain. That should all sound familiar to you. The second one is function evaluation and function operations. Let's just say function operations. So evaluating a function, plugging in, adding functions together, dividing functions, that type of thing. I'm sorry, that's still 2.1. But this is homework 004, homework 005. And the last one, which I'll just get to today, I won't finish it, is something called the difference quotient. Nice writing, Robert. And that is homework 006. So I don't think I'll get to homework 6 today, okay? So I'll get through all of homework 4. Homework 5 is very simple. Just try it. And of course, what do you do when you go to do some homework and you can't do it? You do 3 things. 1, you curse out the teacher and say, what the hell am I paying this guy for, right? Then get over that. And then go look in the notes, go look in the books, go look on the computer, right? And if that still doesn't work, then you're just asking me next class. And maybe I expected you to get it and you go, oh, I can't believe it's that easy. Or maybe I didn't get to it, right? So, but I don't want you spending a lot of time. If you're confused about what you're doing, you've got other things to do, right? So if you get to something that you don't know quite how to do it and you do a little quick research and it's over 5-10 minutes, stop, right? And then just wait for me. There's nothing that we're doing that is so pressing that you must have it done before you get a chance to ask me about it, okay? So just be conscious of that. Maybe I just think it should be a review and you should be able to get it, right? And then, of course, there's always that button there in the homework, right? What does it say? My teacher sucks. Show me how to do this, right? Is that what the button says? So you can always click on that button and watch a problem, and then usually you'll pick it up. And I promise you, in the things that I'm testing on, and the things that are difficult, I'll make sure I go through the detail on it, okay? So this first homework, so homework 4, we're dealing with what is a function, right? And how do I find domain? What is a function? As a human, as a mathematician, as a graph, and then what is the domain? And that's going to come from as a table, as a graph, or algebraically. So those are the things we're doing. Let me show you the book real quick, because I want you to see this, and I want you to read the book. And I know it's hard to read the book. Everybody will have a hard time reading the book. So I'm reading the book here. I'll share it in a second. And I look at the 2.1. I'm sorry. 2.1. And you see here I've got a kind of a little list here of the things that you might have trouble with. So the things that I'm assuming you know, okay? And so they are intervals, so interval notation, solving inequalities or even equations, evaluating expressions, and then rationalizing a denominator. So see, these are some of the things that the book is expecting you to have a little trouble with. And so then it's giving you a reference of where you can go in the book to find it, okay? Now that piece might be hard, but if you say to me, Robert, I want to read up on intervals, can you make a section for me for Appendix A, right? And so, of course, I will do that. You might be a student doing the homework in the book. So the written, right, the end of the section. I have all the solutions for that. So if you want those solutions, all you have to do is say to me, Robert, we give me the solutions for chapter 12 or chapter 2. And I have all of them in a PDF. So if you want them, I will give them to you. I think if you ask questions, when I start doing some interval work, I think you'll pick it up, right? I think we're all pretty smart in this class to be able to pick things up. But if there's ever a time that I'm doing something and you need more detail, please ask. You can ask in class, you can ask in office hours, you can ask via email, okay? And then I will start to learn about, what you need. I would like to just assume you get everything I think you should know, but I understand that's not true, but you have to tell me, right? You have to tell me if I'm a dentist, tell me which tooth hurts. Otherwise, I'm just going to start drilling wherever I want, because that's why I became a dentist. So tell me where you're having trouble, okay? Nice. So here we go. What is a function, right? What is a function? And this should feel like a review, okay? It should feel like a review. So what is a function? I like to start as a human. Like, how would I explain what a function is to somebody if I was just riding in an elevator? A function is a predictable machine, right? Function is a predictable machine. Like when I go in my car and put the key in and turn it, the car starts, right? And I'm pretty happy. I usually don't even think about it, but every time I put the key in, one time in the 80s I had a really bad car, and it would right. Sometimes you put the key in, it didn't start. I would say the car is no longer functioning, right? I'm pissed off. I got to take a bus or whatever, So it should be predictable. Every time I repeat the same action, I should have the same result, right? And so that's how we translate it as a mathematician. So this is our human version. Our math version says for every unique input, right? For every unique input, every time I multiply 7 times 4, I should get the one and only one answer. For every unique input, there is one and only one result. Every time I go put money in the soda machine, hit the button, I get a Coke out. And yes, I say to myself, I'm diabetic, I shouldn't be drinking this, but I don't know what happens sometimes, right? So I put the money in and hit the button, out comes a Coca-Cola. Hit the money, put the money in, hit the button, out comes a live chicken. No longer is this machine functioning. I'm okay with the live chicken. You get the eggs. On some Sunday, you can break its neck and have a nice dinner, right? But I was thirsty at the time. I want this thing to be predictable, right? And so that's the same thing. When I hit 7 times 4 on my calculator, I had better get 28, right? So this is a deep thing about for computer scientists here, that I want things, right, to function correctly. Same thing for biologists, right? If I do an experiment over, it had better not give me a different result, because then I'm starting to doubt, right, my theory on this. Every time I do the experiment that same way, right, I should get the same result, right? So this is still a concept for us in bio or engineering. So we have to talk about a couple of things here. We have to talk about input and we have to talk about output, right? And so our input is coming from this word domain. And so we're talking about input. And we're talking about here allowable x values. Shadows on the floor. Independent variable. And the inside. So when I talk about that, every unique input, I could be talking about any of these types of concepts with me. Some of them will be numeric, some of them will be geometric on a graph, some of them will be algebraic. So if I see my notation y equals f of x, you can really see where that inside comes from. We're talking about the in, right, what I'm putting into that function notation. When we're talking about range, it's no longer the inside, it's the outside. So the outside. So that means the y is my range value, right? So I'm talking about the height of a function. Shadow on a wall. Dependent variable. Right, when we're doing a bio experiment, we're in charge with, all right, what the temperature is, what kind of liquid we're adding in. What we're not in control of is the result, right? We're not in control of the result. The result is dependent. All right, so let's look at some problems. I think we're ready to do some of the homework here. We got to be able to tell if something is a function. We have to be able to tell what the domain of a function is, right? Feeling like a little bit of a review here right now? Yeah? Anybody else? Nice. Jamal, Ryan, Elise saying yes, review. Daria, yes. Yep, thank you. Hands up, thumbs up there. Good, so we'll do some problems, right? I mean, chapter 2 will be easy. Chapter 2 is all about functions. There's a couple pieces of it that are weird. Chapter 3 is about linear functions, quadratic functions, polynomial functions. Chapter 4 is about inverse functions and log and exponential functions. And then chapter 5 is trig. So you're going to see every type of function that you'll see in calculus. And of course, the pieces that you'll have most trouble with in calculus are the trig functions and the exponential and log functions. So let's make it the first time that your Calc 1 teachers will say, oh my God, how did you know all of this stuff? Who was your pre-cal teacher? And then of course if they say, who taught you pre-cal? My name is Joe Smith, if that's the case. All right, so does the following rep a function? Does it represent a function? So I've got f of x equals 2, right? So I might see a table there. So x and f of x, or x and y, right? F of x is the same as a y, right? So 1, 2, 3, 4, and my answers are 2 every time, obvious. Does this represent a function? What's my rule? If I put the same thing in, I had better get a repeated result, right? If I put money in every time, I had better get a soda. So when I put $1 in here, I get out $2. When I put in $2, I get out $2. When I put in $3, I get $2. I mean, I don't like this function, but is it a function?
Yes.
Yes. So I'm looking for where the issue is. The issue is repeated inputs. Since there are no repeated inputs, this looks good, right? If I look at the graph, okay, and we should be able to see what this graph looks like pretty quickly. It's a horizontal line at height 2, right? It's a horizontal line at height 2, right? This is y equals 2. And I'm looking for this thing called the vertical line test, right? Where if I draw a vertical line through someplace on the graph, in fact, if I want to draw it everywhere, I want to think about this vertical line being able to move, I can see where it hits on my x-axis. That's the domain, the shadow on the floor. And what height does it hit? It hits a height of 2 every time. So no matter where my input is, no matter where my shadow on the floor is, I'm always going to get an answer of 2. Are there more than one height? Is there more than one height at this point? How many heights are there? My height, by the way, is in green, right? The height is in green. How many heights do I see at that one point? 1. And that's all. That's what I need for it to be a function. I need it to be clear what the height is when I get there, right? So no matter what x I put in here, I'll get a repeated y, but that's not a problem for me. It's the repeated x's that are a problem for me, right? By the way, what's the domain of this function?
1 to 4.
Almost. I like the answer. I'm looking at that function, right? I like the thought, but why can't I put pi in? Why can't I put f of pi in there? And I'd also get a 2, right? So the question is, the domain is allowable x values. What x values am I allowed to put in there?
All real numbers?
All numbers, exactly. So my domain here in interval notation would be minus infinity to infinity, or that bold R, which is the reals, or all real numbers in words. I always find it funny when we talk about real numbers as mathematicians because no one ever says, hand me that 2, right? Numbers aren't real. They're all, I mean, no one ever says, hand me that piano either, but, you know, but we talk about 2 types of numbers, right? Real numbers and complex numbers. And I think you and I are going to skip complex numbers this semester. We're not going to talk about them at all because you're going to be doing some very advanced math to talk about complex numbers in your life. So I like to imagine taking that purple line and squashing it down onto the ground, onto the x-axis, and everywhere the line hits the x-axis, that's in my domain, right? So that's how I talk about shadow on the floor. Just do another one. How we doing? We okay? Speed okay? Understanding okay?
Yeah.
Nice, thank you. Does the following rep a function? So I'm going to hide f of x from you for a second. And I'm going to say that I have an input and an output of, don't tell me, 0 and 1, 1 and 0, negative 1 and 0, 0 and negative 1. Does this one represent a function?
No.
No, good.
No.
Where's the issue, though? Where's the issue here?
There are 2 zeros or
The repeated x's are really all you have to look for, the repeated x's. So I know that f of 0 is 1. I know that f of 0 is also negative 1. Of course, we'd rather say that as f of 0 is plus or minus 1, but it's unpredictable. I can't tell which one I'm going to get from it, right? And this particular function is x squared plus y squared equals 1. This is written implicitly. This is an implicit function. Explicit would be all the x's on one side. So I would get y squared equals 1 minus x squared, or y equals the plus or minus square root of 1 minus x squared. And there you can see I'm getting that top half of the curve from the positive square root and the bottom half of the curve from the negative square root. So this for me on my calculator is kind of easy to graph, right? So I put in y1 equals the positive root. I put in negative for the, I put in y2 as the negative square root, right? So this is on the TI-83, 84 kind of thing. But if you, a lot of these I would invite you to explore with Desmos, because Desmos is, our calculators are such dinosaurs. They really are. So I'm going to Desmos here. And I'll just say to you, if you're using Desmos, it will eat up your RAM. It's constantly running scripts. So if you are working on something and fall asleep in the morning, your computer will be very, very slow. So x squared plus y squared equals 1. And I get that circle, right? So if you're looking at that circle, you can see I'm going to fail the vertical line test, right? You with me here? I failed the vertical line test a bunch of times. Right, I get a radius, a circle of radius 1, right? And if I draw a vertical line, you see I get an input in red. There's my x value. And I'll get an output in blue. I get 2 of them. And remember, I want to look for the whole curve. I want to look at the whole curve. So, of course, it passes the vertical line test here, right? It only hits 1 point, 1 x and 1 y. But I want to make sure I'm looking at the whole entire curve to check for this repeated input, different outputs, right? How are we doing here? Not too bad, right? And if it's easy now, good, enjoy it, okay? Because it's not that anything we do is difficult, but it's just so much material that, God, is it hard to remember everything. So, but you're going to work on your formula sheet. You're going to get it nice and compact, right? Get as much on there as you can. You'll see I'll do like a step-by-step today. You're going to try and put those step-by-steps on all the time. If you are a student that has a hard time remembering process, or you get nervous and you freak out, right? You want to put as much English explanation on of how to do this type of problem for yourself so that you can save yourself on the test. Is it a big deal if you fail a test?
Yes.
No. Is it a big deal if you get in a car accident? Yes. Right? Let's keep things in perspective here. Failing a test isn't going to kill you, right? So, and you've got a couple of safety nets with me. I'm talking about replacing the worst test with a final, or possibly even dropping a test. So, but, I tell you, they get more difficult, right? So do as well as you can on the test as they go. If you can get A's and B's on the first 3 tests, you could fail the last test and still get an A, right? Of course, you want to make the final exam have the less impact on you, so you want to keep an A or a B the whole way, so that your final exam you could possibly get a D and still keep your A, right? That's the ultimate. My goal was always work as little as I can and still keep an A. And I didn't get all A's, but who cares? Like they say, when I buy a brand new car, I just scratch it right away. Just get used to it. It's going to happen eventually. Let's see. Let's look at a couple of homework problems here. So I'm just going to my Math Excel. And I want to look at that first homework 4, first homework in chapter 2. There's just a couple of more domain things that we haven't talked about in this particular homework. How do you find the domain algebraically is what I'd really like to talk about. So I want to look at a couple of those problems. So I'm looking at homework 4, 2.1, domain and range. And I think I can jump to like homework number 7 or so. Let me see, 7. I did a bunch of the earlier ones. So just so you know, you should be able to do all of those. Nice. So determine whether this one is a function or not. And what's really the key. If I solve this for y, right? If I solve this for y, I would have plus and minus square roots, right? So 3x squared plus y squared equal 1. This is homework 4, number 7. I had 3x squared plus y squared equal 1. Anybody know the shape of this one? What does this look like if I graph it?
Parabola?
Almost. I like that thought. So 3x squared plus y squared equal 1. It's an ellipse, right? So in the direction where the coefficient is bigger, it stretches out. So in the y direction. So the coefficient of y is 3. The coefficient of x is 1, right? So that's an ellipse there. And so you see it will fail that vertical line test. right? If I drew a vertical line, I'd hit the x-axis once. There's my unique input, but I'd have more than one output, right? Everybody with me there? This is a linear function, minus 3x plus 2. And forgive me for doing some of your homework for you. I'm sure you don't.
No, not at all.
You don't mind, right? You don't mind. Y equals negative 3x plus 2. This one's linear. Remember what I talked about domain? Well, you might not remember, but I'll remind you. It's allowable x values. What x values am I allowed to put in this? Am I allowed to put into this thing? Am I allowed to put in a negative 7? Can I multiply a negative 7 by a negative 3 and then add 1? Am I allowed to do that in all we have learned in math? Yes, right? And if I think about this one graphically, at plus 2 with a slope of minus 3, right? Think about this. Is there any issue with this domain? Like if I squash this down, do you see it hits the x-axis? I'm squashing the part that's going above down, and I'm squashing the part that's going below up. I used to would say, you know, I'm walking on this line, throwing pencils into the ceiling. You remember how you did that in high school? You would sit there, sharpen your pencil, and throw it into the ceiling, and it would stick. You never did that? Yeah, I was a punk kid. And over here, I'm walking on this, but I'm dropping a piece of popcorn. So I'm interested in where do I hit the x-axis anywhere, right? So the domain is clearly everything. So my domain here is minus infinity to infinity, or bold R, right? All reals. And so clearly, I can multiply any number I want by negative 3, and then once I get the result, I can add 2, no matter what number I pick, right? So we have to think about what are the rules in domain. When are we not allowed to put an x value in, right? So when are we not allowed to put an x value in? That's really our main question. So our domain issues. Right now, there are only two. Dividing by 0, or an even root of a negative. Those are our only two issues. We will be adding them as we go. As we get to our logarithmic functions, we'll add a new domain issue. As we get to our trigonometric functions, we'll add a new issue. So as we advance later and later in our math careers, we'll come up with new issues, right, for our domain. But right now, we only have two. Dividing by 0, or taking an even root. For us, it's only square root of a negative number, right? And you'll actually learn that you can divide by 0. In Calc 1, we'll teach you that you actually can divide by 0. But right now, we're lying to you, kind of. We're hiding it from you. We also say don't smoke pot, but we don't tell you why yet either, right? Because you could go to jail, or you could like it too much, right? So same thing with dividing by 0. You're going to learn that you actually can, and it's in Calculus 1 that you talk about it. You can actually also take a square root of a negative, but again, we're hiding those results from you because they're a little bit complex right now, and that's kind of a joke. Let's look at this next problem. So this one, I want to find the domain of this function, and clearly I've only got two rules, right? And how do you know that? Because that's what my job is, to teach you the rules. So there's only two rules. Can't divide by 0, can't take a square root of a negative. So obviously I'm dividing on this one, right? So my function is x minus 10 over x cubed plus 2x. So f of x is x minus 10 over x cubed plus 2x. And so the trick is for me to factor, right? X minus 10 over x times x squared plus 2. And then set my downstairs equal to 0. So I can't simplify this at all. If I could simplify it, I should. But now I know that x times x squared plus 2 equals 0 gives me what? That x equals 0. That's the only time it will be true. So that's a value that's not in my domain, because I can't divide by 0 at this point. So my domain is minus infinity to 0, union 0 to infinity, or the bolds minus the singleton element 0, right? The bold, all reals except for 0. And the book wants, MathXL wants the interval notation. So MathXL wants this answer. Let's see if we can do another, right? How we doing here? We okay? Comfortable with this? Nice. The rest of you asleep? Nice. I'm just taking a quick attendance. I forgot in the morning class, but it happens. Life goes on. Let's do one more, and then we'll move on to the next section. So another domain problem. Let's say f of x is equal to square root of x squared minus 2x minus 8. So the book gives you easier functions than I would, but I'm trying to improve the results of the class, and so I'm going to let the book that we picked as a school dictate how difficult the problems are. So this one's a little bit more difficult than the book would give you. But don't worry, if you have me for Calc 2, you'll get to see a very difficult test if you want to join me then. So this particular one, I know what's going on inside here. It's a quadratic that opens up, right? This is a quadratic that opens up. In fact, I could find a vertex, or I could factor it, right? I could factor this one, right? Do you agree? What two numbers multiply to -8 and add to -2? It's -4 and +2, right? Yeah. So I already know that this particular one hits a root of -2 and +4. And it opens up, right? So it had better be doing something like this, right? And I know that for a domain of a square root, I can't have negatives inside of there, right? I can't have negatives inside here. So this green area is off limits to me, right? I have to make sure that that interior x squared minus 2x minus 8 is greater than 0. And obviously I get the union from minus infinity to 2 and from 4 to infinity. And look at my notation there. Can I get to minus infinity? Can I ever get there? Well, start walking. No, you never get there, right? Can I put in the -2? Am I allowed to put in the -2? Well, if I put in the -2, I get square root of 0, and I know the answer is 0, right? So I can put in the -2. So that's why I have that square bracket. When you can put the answer in, you can use a square bracket. When you can't put the answer in, you use an open bracket, right? So can I put in a 4?
Is that supposed to be a -2 or a +2?
Yes, a negative. Thank you. -2. Thank you. I was just double checking that you were paying attention. That's all. Yeah. So right. So open. Sorry, that's not a curly bracket. That's an open. Open when I can't get there. Square when I can get there. Is that bothering anybody? Anybody a little iffy on the interval stuff? Nice. So that's it for homework. Homework 4. Homework 5, I think you can just do without me teaching it. So, but again, I'm encouraging you to curse me out if that isn't quite true. Let me see if I can get back to homework. Let me see if I can get back to homework 5 quickly here. Yes. So homework 5, I'll just look at a couple problems and you'll see that you already know how to do it. So homework 5, function arithmetic, evaluation and arithmetic. So plugging numbers into the functions, right? Easy. And then putting functions together and then finding the domain. The key about that piece is don't think about the theory, just put the functions together and then find the domain, the way I've been doing. So, for example, in question 1 here, I've got a function, it's a quadratic, right? 4x squared plus 2x minus 4, and the first question is asking me plug in 0. I mean, so this is pretty easy. I would say if it's difficult anywhere, it's difficult in part H. It says plug in x plus h, but I'm going to do that in the next section anyway. So I'm kind of teaching you how to do some of the more complicated things in homework 5. I'm teaching you them in homework 6. Okay. Let's look at another one. I mean, this one is really nasty for like F. So letter F or letter H. But again, I'm going to teach you how to do it in homework 6. This one says take my two functions and add them together, right? Do you see where it says that anywhere on the page? Take the two functions and add them together. So it says f plus g, right? F plus g. So just put the two functions together. It's simple. Right, what do I get there? I get 7x squared plus x minus 5, right? So, I mean, then take my new function and figure out the domain. Is that easy here? What's the domain of this particular function I have here? Well, it's a quadratic, right? Go ahead, Ryan.
It should be.
Well, it's a quadratic, right? So imagine how wide it gets. How wide does it get? Yeah, everything, right? So if I squash it down onto the x-axis, it's going to hit everywhere on the x-axis, right? So the domain is, it's all real numbers, right? Why wouldn't it give me, I need a minus infinity.
There's B. You can hit B.
Oh, okay, thank you. Just, what are you saying? I can hit B.
No, like the answer choice. It says.
Sorry. I get you. Thank you. I don't have to type anything. Thank you. See, I don't even read. I don't want to read. So these are pretty easy. I don't think I really need to teach anything here. It turns out that the domain is the intersection of the domains of the original functions, but I don't need to talk to you about that theory, because what I need you really practicing is just finding the domain of an algebraic function, right? That's really what the key is here. And then later you can learn about this more complicated piece here. Now multiply these functions together, etc., etc. Divide these functions. So anyway, we're done. Let me do the next section because that's the tough one. It's a lot. This is a lot, but we only have about 11 minutes of class left, and I know it's pretty tense at times. You know, I don't like going camping, right? So because it's always kind of intense. There's just a lot of material to cover, but I think 2.1 is pretty simple. But anyway, let's talk about this last section here. I won't get this done, so I'm saying for homework 6, you don't have to start it yet. But what we're talking about is the difference quotient. So this is 2.1. It's related to homework 6, and it's called the difference quotient. So I'm interested in something called a secant line. So I'll take a particular function, x squared, and I will grab 2 points on the function and draw the line between them, and that purple line is called a secant line. So we want to come up with a formula for the slope of the secant line. And the way I'm going to do that is label my 2 points x1, y1, and x2, y2. So the slope of the secant line is going to be m equals our same old formula that we learned, I don't know what grade, y2 minus y1 over x2 minus x1, right? But I'd like to make this a little bit more sophisticated in the sense of that now I know y's actually are f of x's. So this is actually f of x2 minus f of x1 all over x2 minus x1. And I don't think that's difficult for us yet, but we want to go one step even further. We'd like to define this first point as just plain old x, and the second point as x plus h. So maybe I redraw my line, sorry. I'm going to call the first point x and the second point x plus h. So this height comes from, that point comes from x comma f of x. And the other point comes from x plus h comma f of x plus h. And there's, again, my secant line. I missed, but you know what I mean. So I want to redesign this slope from my 8th grade version or 9th grade version, or if you were like me, 10th and 11th grade is when you learn slope until you finally learned it. So, but I want to rearrange this. So what do I get for my difference quotient, which I'll often just label as a dq. I'm going to get f of x plus h, right? My x sub 2 becomes x plus h minus f of x. Go ahead, say that again. Sarah, say that again. Over x plus h minus x. So I'm replacing my x sub 2's with x plus h's. I'm replacing my x sub 1's with x's in the numerator and the denominator, and you see that something simplifies here. Right? My x's go away down here. So my final answer for my difference quotient is f of x plus h minus f of x all over h. Difference meaning I'm subtracting, quotient meaning I'm dividing, difference quotient. This particular formula will give me a slope of a secant line for any x value and for any h value. Right? So I no longer need 2 points. Right? I no longer need an x1, y1, and an x2, y2. Now I only need an x and an h. Where is the first x and how far away is the second x? That's it. X and x plus h. That's all I need. Now we're going to have 3 types of functions that we're going to work on the difference quotient with, and all through Calc 1 we will do this. And so that's why we really are stressing this in pre-cal. We're going to deal with it with a polynomial function. We're going to deal with it with a rational function, and we're going to deal with it with a radical function, square root function. I don't think I'm going to get to all of them today because I have 6 minutes, but I want to at least do one polynomial function today. Okay? How are we doing? We okay with me? And you have to trust me. It's hard to do this because, one, I look the way I do. Can't trust anyone that looks like me, that's for sure. But you have to trust me that you're going to see something happen in calculus with this that it's just so beautiful. All right, so now I sound crazy. So now you can't trust me either way. So, but I'm going to torture you a little bit this semester. I got to do all of this stuff. I got to get you to see all of these functions so that when you get to calculus, you're not missing any of the pieces, right? So again, I apologize, and I'm okay if you hate me for the rest of your life as long as you pass everything. That's all I care about. Let's find the difference quotient let's do a tough one. I did an easy one on the other video if you want to just watch that. So if f of x equals x squared, the dq turns out to be 2x plus h. Okay, so you could try that one on your own. Let's do a tougher one. Let's say f of x equals x minus x squared, and let's find the dq, find the difference quotient. Okay, so I have a step-by-step for this. So step 1, find f of x plus h. Everywhere there's an x, plug in an x plus h and simplify. Step 2, find f of x plus h minus f of x. So I'm going to take the work I did in step 1, take the result from the original function and subtract the two, and I'll show you the secret there. Step 3, find f of x plus h. So step 2 is find the difference. Step 3 is find the difference quotient. And we're going to simplify and check a point, or check a slope. Oh, hideous. Ready? We're almost done today. 3 minutes. It's going to be real close. All right. F of x plus h. Everywhere there's an x, I'm plugging in an x plus h. And notice that I've got, my original function is x minus x squared. My new function is empty parenthesis minus empty parenthesis squared. The key is that inside the parenthesis must be empty, and I'm plugging in x plus h. I'm going to work on that algebra a little bit. So the first parens mean nothing, but the second parens means square, right? So again, the first parens mean nothing. The second parens is going to give me my favorite 4-letter F word. Okay, you were thinking of FOIL. That's fine. X squared plus hx plus hx plus h squared. And I use square brackets for multiply as well. Right about this time when I'm taking this next corner, I should be hearing, slow down. I'll change my speed. If I'm your Uber driver, I'll change my speed. I'm not changing the radio though. I don't care what you say. I'm in control of the music. So I'm distributing a negative now. And then finally combining any like terms, but I don't have any, so I'm done. How are we doing here? Sarah, yes, you okay? Now, I know my original function, and I can see where it matches up, right? My original function is x minus x squared, so I'm going to put that function right underneath where the x and the minus x squared exist. Because remember what I'm going to do, I'm going to subtract them. And here is the key here, is that everything without an h factor in it will disappear. If it doesn't, you made a mistake. So the x's will disappear. There's no factor of h there. The x squareds will disappear. There's no factor of h there. So I'm subtracting these, right? And what do I get? I get h minus 2hx minus h squared. Everything that's left better have a factor of h in it. And guess what? I'm done. I can't make you stay any longer, but now I'm going to divide by h, and I'm going to factor an h out, right? Factor an h out. I get a 1 minus 2x minus h all over h. And then there's finally my difference quotient, 1 minus 2x minus h. So that's a tough one, okay? But we'll do several more next class. On Friday, we'll do several more. It was a little rushed, so but remember what I said. You don't have to do homework 6. Wait for me. Let me do some more difference quotient work on Friday, and then you'll be able to do that homework over the weekend. I'll stick around if you have anything for me. I do have an advising appointment at 1:30, so but otherwise I'll see you Friday.
Thank you. Thank you.
See you Friday, Professor.
Thank you. See you Friday. Thank you. Have a good day.
Thank you.